Yeah, as Kim mentioned, this work is really focused on my PhD dissertation, which is moving towards sort of an adaptive management strategy to try and help reduce community risk to wildfire. And so really this focuses on trying to understand the potential for a specific tree species, Quaking Aspen, to reduce wildfire hazard. And so this project, and I'll speak about the funding a little bit, is a partnership also with Colorado State University. So a shout out to Dr. Sarah Hart in the Department of Forest, Marine Land Stewardship. And our funding is through the Joint Fire Science Program. And I'll talk a little bit more about that. So why Quaking Aspen? Why are we interested in aspen? This photo here shows us the Pando aspen clone in Utah, which is one of the largest living organisms in the world. And so aspen is a single organism, or at least many large organisms across the landscape. And we've heard a lot about the wildfire impacts to communities and how that's increasing. We know that the wildland-urban interface, or where people live adjacent to flammable vegetation, has grown. In fact, grown by 32 million between 1990 and 2015. So what this means is that we really need to come up with, there's a need to better manage community risk and develop active forest management solutions that reduce wildfire hazard near communities. One such management approach that's been proposed is the expansion of deciduous forest types, such as Quaking Aspen, whose traits have been associated with less severe fire behavior than their neighboring conifer stands. And Quaking Aspen is the most widely distributed tree species in North America. They provide numerous ecosystem service benefits. These include wildlife habitat, species diversity, hydrologic functioning, recreational value. And what we're interested in is the idea that aspen forests may also act to moderate fire severity, intensity, and spread rate across landscapes. So just to provide some context about what we do know, and I put a question mark here because of course all of this is with a grain of salt, and this is part of what the work that we're doing. Quaking aspen and wildfire are linked. So aspen respond to canopy opening events such as wildfire, timber harvest, or blowdown. And they've thrived with fire as an important disturbance mechanism. And their distribution across landscapes is often driven by disturbance regimes broadly. We also know that there's an association with less flammable traits. So aspen forests have often been referred to as asbestos forests due to their resistance to fire. So traits that may, some traits may be higher surface fuel moisture, greater canopy base heights, and lower canopy bulk density. For example, we've seen in experimental burning plots in the boreal forest of Canada that wildfire behavior is greatly subdued in forest stands that are composed predominantly of aspen. We've also seen in research and observation that aspen forests are less likely to burn than their conifer neighbors, both because ignitions are less likely to carry fires, and spread is just a lot slower in these forest systems. Some observations have also suggested that aspen presence may increase the effectiveness of wildfire suppression operations. And this is an area of further research and something that we're trying to tackle here. So we also know that there's this difference between seral and stable aspen stands. So seral stands are successional and they tend to be transitory, whereas stable aspen forests tend to stick around for a long time. What we're seeing in recent events is that we may have a future dominance of quaking aspen in some areas due to short interval compound disturbances. So things like drought and insect disease interacting to sort of decrease the regeneration of conifer and increase the likelihood of aspen presence. So this is an image of that experimental plot that I mentioned. And so what we can see is that these plots were developed and set on fire. And the bottom right-hand corner, what we see is the fire burned through that right side of the plot is all conifer, the left side is all aspen. So the fire burned as a high intensity crown fire and then hit the aspen forest and essentially went out. So some unknowns and things that we're hoping to tackle with this work. What does the future look like? And that's a big question, I think, of this entire conference. But we know that in some areas, aspen has been declining. In others, it's been increasing. So we're not really sure what the future looks like, and we need to get a better understanding of how aspen is distributed across the landscape and what that will look like in the future. If aspen does moderate fire behavior, how does it do so and when? So we know that it's likely not going to be in all scenarios, so we're trying to understand how and when it does. And then one of the big questions here is, does aspen around a home or a community make it less likely to burn, or at least help firefighting operations? So to answer these questions, we've received funding from the Joint Fire Science Program with support from our partners on the left here, Rocky Mountain National Park, Town of Breckenridge, the Nature Conservancy in Colorado, and the Southern Rockies Fire Science Network. And this infographic really outlines the 6 aims that we hope to accomplish throughout this work. Now, I'm not going to get into detail here, but again, happy to talk offline or answer questions in the discussion. What we see is aim 1, we need better maps of aspen coverage. So that's the first step, is building better maps based on high resolution satellite data. And then we want to quantify the influence of aspen presence on wildfire activity and suppression operations. But then we want to move to actually producing maps of current and future habitat suitability and suitable areas for conversion of conifer forest to aspen, or at least of expansion of current aspen forests. And then in the end, simulating the potential effects of aspen conversion. And this is really where we see the RAD framework come in, because we want to test these different management scenarios and what that would mean for both the ecology and communities involved. And we are currently on aim 1, mapping aspen. So we have a lot of work to do.